Hello and welcome to GDA Conversation. I am Emad Muhasein, the Capital Efficiency Division Head of Saudi Aramco Domestic Refining and NGL Fractionation Admin Area, and at the same time, the Chairperson of the Project Management Technical Committee of GDA. GDA, which is the Gulf Downstream Association, which is a non-profit organization, was established in Bahrain in the year 2016 by the founding members, which are Saudi Aramco, ADNOC Refining, Kuwait National Petroleum Company, Kuwait Petroleum International, and BABCO. GDA aims to bring leading downstream players together to further develop the industry and draw mutual interest and benefits from sharing knowledge and best practices. GDA Conversation is a series of webinars that GDA has been currently arranging, especially amidst the COVID-19 pandemic, to meet this objective. Today, it's my pleasure and honor to host ANGARA Company, which is an associate member at GDA, the opportunity in this webinar to introduce its cognitive cleaning technology. At the same time, I am grateful to GDA Technical Committee's member who have dedicated part of their priceless time to join us as well today. I would like to highlight that we have GDA attendees representing 5 technical committees: the technology, energy management, commissioning and startup, plant reliability and integrity, and project management. Now, please let me introduce our colleagues from ANGARA. The first speaker is Mr. Ilya Rodin, who is the co-founder and CEO and board director of ANGARA, with lots of rich investment and experience in this field. And the other colleague, Mr. Eduard Cherednik, who is the Chief Digital Officer with more than 20 years experience in the industry. Without further ado, I would like to give the floor to our colleagues, Eduard, to start his presentation.
Thank you for inviting us to speak today. It's a great honor to be with such a great company. Our plan is to go through some slides. We will, for the matter of time, we will squeeze on our presentation as much as we can. So to leave as much time as possible for Q&A session, so you can ask us any questions. And I will then jump to the presentation immediately. So this is the picture most of you are familiar with. All the refineries in the world are suffering from fouling, and in different degree, but we all know that it is a big problem. In ANGARA, we tried to quantify the effects of the fouling on the environment, on the economics of the refining and petrochemical business, in terms of what is the effect and what is the cost of fouling across the industry. And then we will walk you through some potential mitigation scenario which can help you to improve and uplift the refining margins. So from our perspective, fouling is like a tax. It works regardless how much effort you put, fouling is happening, and everyone pays this cost. So our target is to reduce the 20% fouling from chemical and petroleum industry to the lower amount. We did a model, quite large model, and then we cross-matched the model results with the actuals number on with the company reports. In the model, we took 3 basic scenarios, like 10% dirty, 20% dirty, and 30% dirty, which is very aggressive fouling cost. And we found that the model works well and it fits the company reports. The average fouling which refiners are facing is up to 20% dirtiness case. We see this as a dot for Shell. It is like 47.1 million tons of CO2, and in the clean conditions, it can be reduced to less than 40 million tons of emissions. And the cost of the fouling can be quantified in monetary terms. So jointly, world industry is losing over $15.8 billion a year costs of the fuel overconsumption due to fouling. So the thicker the fouling layer, the less energy it allows to recuperate. So you need to burn more fuel in your fire heaters. And by burning fuel, first you spend money, and second you emit CO2. And those are 2 effects which are very negative for the industry. In the case to elimination of the fouling, the refining margin can be improved by 30 to 80 cents per each barrel, which is quite significant improvement. Overall, industrial hygiene has a huge potential for petrochemical, for refining and power generation industry. If we look into the refining and the petrochemical numbers, it is very much comparable with the renewable energy. So jointly, renewable energy sources of solar and wind, they generate 1,800 kilowatt hour, and the industrial hygiene potential is 1,800 terawatt hours. So it is very huge potential. And this industrial hygiene has a significant potential to contribute to the global climate change goal, let's say 2%. And our estimate it is, let's say, like 1/10 of the overall potential improvement to the Paris Agreement without any capital costs investments. And speaking of GCC area, we believe that overall potential of the industrial hygiene in the refineries only is slightly above $1 billion a year potential savings. And if we combine this with the upstream and the petrochemical industry, it could go up to the $2.5 billion. That's quite a lot of money. So now I want to give the floor to my colleague Ilya, our CEO, who will walk you through some our core technology, AlfaPEROX, and then we will discuss how we.
Thank you, Eduard. I'm happy to speak to you, gentlemen, and present our technology. So we see great potential. But as any technology, like any building, sits on a foundation, and for all our levels of innovation, AlfaPEROX as our core chemical technology is the foundation, which is basically a product innovation and a family of recipes for heat exchangers cleaning. Next slide, please. So think of AlfaPEROX as a technological platform, a family of recipes for non-disassembly cleaning of heat exchangers. As you know, probably for oil and gas industry, where fouling inside of heat exchangers more often are like non-chemically inert. That means non-chemically reactive or chemically inert. That means that it's very hard to remove them by conventional chemical methods of cleaning, because this fouling consists of like several components, and at least like 30, 40, sometimes up to 70% of these fouling components are not reactive. That means it's only mechanical. There is only mechanical way to clean them. So basically, what we achieve, we introduce hydrogen peroxide as an active component, which allows to impact gently on the structure of the non-reactive part of the fouling. So we use also other chemicals to dissolve the reactive part of the chemicals. But this hard part, which normally remains after chemical cleaning, we can remove. And in this way, we can clean heat exchangers with extended surface in non-disassembly way. So basically, we have experience working with shell and tube, spiral heat exchangers, plate heat exchangers, and different types of materials. And because hydrogen peroxide applies also like creates a gentle turbulence inside of a heat exchanger, and gentle because we use very low concentrations of hydrogen peroxide, it allows us with turbulence to remove fouling from any spot of a heat exchanger. So basically, we extend very much applicability of non-disassembly cleaning. And that's our uniqueness of our approach. Next slide, please. Of course, we pay a lot of attention to the safety of the equipment. So basically, it's our topest priority. Here is one of the examples of the corrosion reports from the third-party research lab. This is from Gubkin University. It's the topest oil and gas institution in Russia. We did it for one of our international clients. If you can see on the table on the lower right side, the corrosion rates are very low. And if you multiply these numbers, so these are millimeters per year, and if you multiply these numbers by the amount of hours, the exposure of a metal to AlfaPEROX, so you can understand that there is next to zero corrosion. So that's also a big advantage comparing to other chemical ways of cleaning of heat exchangers. Next slide, please. Here I would like to present some cases. This is one of the cases from Russia. It's TANECO Refinery. So here we clean the plate heat exchanger AlfaPEROX. So it's, as you know, these plate heat exchangers are very efficient in terms of heat transfer coefficient. Sometimes the HTC is 3 times higher comparing to the shell and tube heat exchangers. This is tar and oil heat exchanger. And we deposit about 2 millimeters. So that's not a lot on one hand, but actually the distance between plates are about 2 millimeters, so 2.5 millimeters. So it means that this heat exchanger was almost like 100% full with filled with fouling. And as a result, it, of course, to the reduction of the heat transfer coefficient significantly. Next slide, please. So after cleaning, you can see the results. The thermal gradient increased from 9 degrees on the hot side, on the tar side, to 65 degrees, 65. So imagine how much of additional energy is transferred by this heat exchanger, and how much of non-burned fuel is there, and CO2 emission reduction as well. So, of course, we also reduce the pressure gradient after cleaning, so it's obvious, and it also allows to save on the required electricity, required power to pump the tar and oil through the heat exchanger. Next slide, please. This is another example from Moscow refinery, from GAZPROMNeft. We did the cleaning of a butane cooler. So you can see that the unit itself, it's above ground 60 meters, and we placed our equipment on the ground level. What is interesting about our equipment, so it's standard equipment for chemical cleaning. So that means that we can use local service providers in GCC to provide our technology to clean heat exchangers. Next slide, please. Here's economics behind this cleaning, and these numbers is not our calculation. These numbers are confirmed by the refinery. So each day the unit is offline. So this unit cools butane to dissolve it in gasoline line. And each day the unit is offline cost the refinery about $60,000 US. So only because of a time of a reduction, of a downtime reduction from 72 to 23 hours, AlfaPEROX cleaning saved the refinery about $90,000 US per one unit per one cleaning. But if you look into the table on the left side, so you can see that before cleaning, the thermal gradient was less than 1 degree. That means that this heat exchanger didn't work for some time, maybe several weeks or some months. That means that a significant portion of this $60,000 US refinery lost during all this period. And after the cleaning, the thermal gradient became almost 40 degrees. But imagine if there would be a system in place which calculates the perfect moment for the cleaning and does it without human interaction and does it all the time. So in this case, the system could prevent such bad situation with this bad thermal gradient. Next slide, please. So basically, here we are coming to the next level of innovation, the cognitive cleaning, which is based on the core chemical technology, AlfaPEROX. And basically, cognitive cleaning is a process innovation, which is a fusion of seamlessly integrated AlfaPEROX as a chemical solution and smart schedule maintenance as a digital solution. I invite Eduard here to come back and, yeah, please.
Thank you, Ilya. Wow. So far we've discussed about fouling and its effect overall on environment, on the refinery costs. We've also discussed the AlfaPEROX, which is a chemical which has the potential to remove the fouling, replacing the need for mechanical labor. So it can be done without disassembly. But the problem here is that the fouling are very much different from one heat exchanger to another. And therefore, the cleaning solution and cleaning recipe should be tailored to each individual heat exchanger. Therefore, we developed a technology called cognitive cleaning. Cognitive means that we do it in a closed loop. So we collect the data throughout the entire process of cleaning. We do machine learning and physical analysis of the recipe, of the samples, and we integrate the knowledge into the next cleaning. So overall, cognitive cleaning has its three components. First one is a smart recipe. It's basically we need to understand the fouling and come up with the right solution and the right timing, how long we should treat the fouling with different components of our solution. On the second part, smart maintenance, we need to understand when it is the best time to clean the heat exchanger, because some fouling can have economic effects, some fouling is not has a very much impact in the fouling, the costs. On the other side, we need to incorporate the knowledge about timing and the cost of cleaning. So all this of that is done in the smart maintenance part. It can be also done with with some of our partners, companies like KBC Yokogawa or any other companies who are specializing in smart maintenance technology. And the final component of cognitive cleaning is a smart cleaning. Smart cleaning is basically based on the concept to give work to local communities. As ANGARA, we are a technology provider. We don't plan or we don't really want to take jobs from your local communities. All we want is to empower these people with the new technology and help them to be successful for you. Jointly, cognitive cleaning improves all key components of Solomon index, like mechanical availability, personal index, and energy intensity index. as we already had mentioned, the cognitive cleaning implementation in the enterprise allows to uplift the margin significantly from 30 to 80 cents per barrel, subject to different refinery and different market situation. And also, regardless of the market situation, we help to reduce CO2 emissions by 15 to 20%, which is a great deal. In our economy, everyone now is very much cautious and very much conscious about the climate changes and the ecology. So this is a very much important topic. On the where the money coming from? It is very simple. The relative heat transfer efficiency degrades over time. It is not a linear process. It depends on the flow and on the specific fluids. But since the industry inceptions, engineers started to build a bigger heat exchangers to accommodate the falling deposits in the heat exchangers. And the problem with this approach is that the average efficiency level is very low. With the cognitive cleaning, we can do very quick turnarounds, very quick cleanings, non-disassembly, no need to remove the heat exchanger from where it is placed. And with that, we increase the average efficiency level by far. And it has a dual effect. First, it brings a higher margin, and then it allows to cut the CO2 emissions. And this is just only one way to get benefits from the cognitive cleaning. This is one of the implementation of the heat exchanger monitoring system based on SEEQ, very popular tool. And here you may integrate all the available data, sensor data, which you have for the heat exchangers on the flow, on the temperature, on the pressure of the fluids, and you can calculate the overall heat transfer coefficient and make some predictions on the analysis of this data, and schedule the cleaning and also control the entire process as you want. And that was accompanied how to implement these smart chemicals and implement it on the enterprise level. The next level of our solution is more of a business innovation, business process. It is based on a new philosophy, which might be very familiar to you already when you do with the water providers and the electricity providers, probably with some IT providers. It is based on the concept of service level agreement. So instead of being responsible for the cleaning by yourselves, or having the traditional approach when the contractor and customer have different targets, one wants to increase costs, another wants to decrease costs. We designed the Cleanliness Lab, which allows to implement the benefit sharing approach, which is the higher the savings, the bigger the overall payment made to the partner. And it is how it works. This approach allows you to de-risk the cleaning process, and we basically share the risk of the implementation of our technology, and it also allows to switch and unlock the value of SLA model for the heat exchangers and transfer it to the energy efficient long-term contract, and seamlessly integrate your digital and cleaning solution into one overall big approach. And I will accelerate now. This is very important subject we are approaching. Why we are doing this? You already know very well that there are very efficient heat exchangers in the industry, plate heat exchangers, but their implementation is very, very rare because there are certain problems to maintain the equipment. And some companies, like our customer here, they tried to replace the entire preheat train from shell and tube to plate heat exchangers. So they basically bought 26 new heat exchangers from Nexon, and they achieved actually great results. It was, the performance I can describe on the next slide, but they also faced the unprecedented challenges to maintenance this equipment because the traditional approach and the mechanical water hydrojetting was not really helpful to clean this equipment, and they had significant challenges. So they came to us asking to clean those heat exchangers. And to the left bottom, you see the picture of one dirty heat exchanger. It is almost clogged. So normally it should be like 5 millimeter allowance between the plates, and it is like over a millimeter of fouling on each side. And the picture on the right, it is after the cleaning. So we did it non-disassemble, seamless way to remove the fouling from the heat exchanger. And it is very interesting because it unlocks the barrier for the industry to implement the new equipment, to implement the plate heat exchangers in existing refineries and achieve even higher levels of the efficiency beyond the ones you've already seen with the switching to clean and hygiene. So it is a combination of modern hardware and clean-as-you-go service model, which in this case empowered over 42% fuel reduction and associated CO2 reduction. Basically, the refineries saved over 130,000 tons CO2 per year from the implementation of this. And this slide is based on Department of Energy, United States Department of Energy's publication. They compare the current typical energy intensity on American refineries. They also put some state-of-art refineries data on their energy intensity. So you see that the current typical energy intensity is over 109 BTU per barrel, and the best refineries achieves like 94,000 BTU per barrel. From the implementation of the new hardware, refineries can get much higher savings and higher margins on refining margin. This is a very good case, and it is possible to implement only with the transition to the new service model, which we've just presented. So that was a quick overview. Sorry for if I had to speed up a little bit in my presentation. So now we've saved some time for Q&A. So Emad, floor is yours. Please turn on.
Thank you very much, Eduard, and thank you, Ilya, as well, for your rich presentation, which you have tried successfully to decrease to the level that we can have an opportunity to give to our colleagues in the committee. Before I turn the floor to everybody for questions, let me ask, if you don't mind, I have something in my mind. Eduard, in Saudi Arabia, actually, we have the cheapest energy costs, you can say. And as you know, for example, JVs in Saudi Arabia, we give them almost only third of the fuel and feedstock price. So today, what I have seen in the case that you have for in Russia, in the refinery, you showed an excellent optimization when it comes to the time. Instead of 3 days, maybe it is only 1 day. But as you know, net gain, you talk about how much you save and how much you lose. So if I saved in the cleaning time, but I have also cleaning cost, but also the energy I have cheap, so I am not gaining that much with this one. How do you think that you can explain to me that this technology is adding value to me in Saudi Arabia, especially?
Thank you, Emad, for it is actually a very great question, and it has a lot of facets. Yeah, and I can probably talk for 1 hour, you know, to cover all the potential effects from the savings from the transition to industrial hygiene. And I would just put them into, let's say, different levels of, value, adding value to, to the refinery. So first one is very simple. So the energy you use is the net energy you don't, sell. So you can, of course, take a lot of energy and use it for internal purposes, but this is energy which normally can be sold and, for the higher price. That is quite obvious. Second one relates with the CO2 emissions, which everyone in the world is trying to, take under control. The second level of value is related to the reliability of the equipment and on the quality of the heat exchange. So in some processes, it is very important to have the guaranteed value of heat exchange. If you go beyond below these values, the quality of your final product can go down, and that is a very unlucky situation. At the same time, under the fouling, it is a perfect conditions for so-called fouling corrosion. And the fouling corrosion is a reason actually for every fifth major explosion in the in the industry, based on the recent study in the European Union, that it is non-rotating equipment. It is very hard to monitor and control the contours of the flows, and corrosion is a good friend of fouling. So, so the more fouling we remove, the less risks we have. And of course, another potential value for the refinery would be to significantly reduce the energy costs. I mean, if you cut even the cheap energy by half, but on the scale of the entire enterprise, it is a huge saving. That is basically overall framework of the answer. I can detail maybe each line of it more in detail if you wish.
Thank you very much, Edward. Definitely, I have lots of questions to ask, but I need to give the opportunity for our colleagues. I will go first to our chairman of the technology team, who is Aqil Al-Muharraqi, please.
Hi, everyone. Just regarding the Cleanliness Lab, I mean, for this option, I mean, does it have to go through a long-term agreement? I mean, does it have to be through a full-time representation from your company in the refinery? How this is handled?
Oh, that's a great question. Thank you for raising this point. Of course, there is no point to make a transition for 1 or 2 heat exchangers in the refinery, and it is a process. And normally, there is existing process in every refinery, and all the activities needs to be very highly coordinated. We need to implement the cognitive cleaning. We need to build the access to data so we can analyze your data. We need to have access to your technologies, and normally it works as a team. So we build a plan to go through the entire refinery or entire enterprise with the scope to identify heat exchangers which can be added for new Clean-As-You-Go service model. And normally it is like any other project. It is done in the co-located joint teams where our engineers work jointly with your engineers to produce a product. Physically, it can be implemented differently on different setups. It can be a virtual team, or it can be a physical team actually placed on the refinery. It depends on the scope of the project and on the size of the project. So we can go both ways. First, we can start with the virtual lab and do some first implementation of the process on, let's say, 1 preheat train. If we go beyond this and we incorporate more and more units of the equipment which we need to monitor, then we need to build kind of a physical presence, and our engineers can work together to facilitate the transition to a new service model.
Okay, thank you very much. Any further question, Aqil?
No further questions. Okay.
Edward, regarding the Bakinox exchangers, for example, of the diesel hydrotreater units, I am sure that you are aware that we are facing a really challenging time when it comes to cleaning. Does this technology address this issue as well for the Bakinox?
That's again a great question, actually. And you know, all over the world, whether in Russia, in Saudi Arabia, in Southeast Asia, in Malaysia, in Thailand, we are visiting refineries. All the time, people are raising questions about Bakinox. So this piece of equipment is very efficient and replaces like several heat exchangers with the same time increasing the efficiency, but it's very hard to clean it. And basically, we acknowledged this problem back in 2018, end of 2018. We have already received some samples from one of refineries in Southeast Asia. We have established the contact with the Bakinox itself. You know, it's a subsidiary of AlfaPEROX. We visited them, had like a discussion how to move forward, and basically now we are in the process of designing of our cooperation. So basically we want to develop several recipes, ready-made recipes for Bakinox. So what is good about Bakinox? It's pretty much standard, expected to be standard fouling all over the world, maybe with slight variation. And basically we want to create a repository of such fouling and come up with several ready-made recipes for Bakinox. And we want also to certify them by Bakinox, and they are willing to support us. I mean, Bakinox is willing to support us here. So basically, we are in close contact with them. And if you would like also to participate in this program, to accelerate our joint efforts with Bakinox, so please let me know, because like more fouling from Bakinox is more interest from clients could accelerate very much our efforts with the Bakinox team. Maybe. But generally, the fouling samples we have received from Southeast Asia, we are able to deal with them.
Okay, I will come to, thank you very much, Ilya. Let's go back again to Aqil. Go ahead, please, Aqil.
My question is regarding, actually I have two questions here. One of them is in the GCC refineries. I'm sure you are aware that we are using salt water all over the refineries for cooling. I mean, and with salt waters, normally you have a lot of fouling like seaweeds, silt, biological growth. I mean, can this be handled by your technology as well, or?
Yes, it can be handled by our technology. And we also have a lot of experience specifically working with sulfates. And I know that a significant portion of this fouling in seawater cooling heat exchangers consists of sulfates.
But when you said it can be handled by your technology,
it can
I mean doing it online, right? Online it can be done. I cannot imagine how you will get rid of seaweeds online. I mean,
it's not online, so we have to stop the particular heat exchanger to and close loop.
So this has to be offline then.
Yeah, but it is cleaning in situ, so you don't need to disassemble the equipment, so it's much faster than mechanical cleaning.
Yeah. My other question: does your technology work better for some fouling materials compared to others, or?
Yeah, actually, we have several types of fouling where we have, like, I would say, very limited competitors in terms of core chemical technology. So first of all, it's everything what is related to the coke or pyro coke built under the 400 degrees Celsius temperature. The second one is everything what is related to sulfates. We are very efficient in dealing with sulfates, barium sulfates, calcium sulfates, etc. And with some other applications. But what is like the key here is that we extend very much the applicability of non-disassembly cleaning. Even if you have like very limited amount of non-reactive part of the fouling, like let's say pyrocoke, let's say it's only 20%. And it seems that like other conventional chemical methods can remove it. I mean, clean the heat exchanger. This remaining 20% works as a sponge, which allows a much faster build-up of a new fouling. So basically, when you do the non-disassembly cleaning, you have to look at two parameters. The first one is how efficient the cleaning right after the cleaning. I mean, how good is increase in HTC, for example. And the second set of parameters is how is this effect works in the longer run. Because sometimes if you use like conventional solvents, for example, to dissolve this like this part of a fouling which can be dissolved by conventional chemicals, so you don't dissolve these hard materials. And because these hard materials remains there, new fouling starts to build up much faster, and efficiency deteriorates also much faster.
Thank you very much, Aqil. And let me move to Danada Sekar. Please go ahead, Sekar.
Hi, good afternoon, and yeah, thank you for the nice presentation. Yeah, I have maybe a few questions, but to start with, if I understood right, this particular method still would need the isolation of these heat exchangers and then connecting to another chemical circulation system and then clean it. Am I right?
That's correct.
Okay. So the 24 hours that you mentioned, is that the circulation time, or maybe isolating the exchangers, then de-inventorying or doing a decontamination and then handover? So is it covering the entire process?
In this case, it was the entire process, 23 hours. In our example, I have presented with shell heat exchanger or with plate heat exchanger. The actual cleaning was about 6 hours, and this heat exchanger was very, very dirty. So, like, if you will do it in cognitive cleaning manner, I mean, to maintain certain level of cleanliness, that means that the actual cleaning could be even much faster in 6 hours.
Okay. Yeah, thank you. And then will it change from for different types of heat exchangers, or you typically achieve this cleaning in a specific time?
It very much depends on the type of heat exchanger, how big it is, how like wide are the inlets. Like there was also a question that some of the tubes on our pictures seem to be dirty still after cleaning, but that's because we did the cleaning through a 1-inch inlet. So it's all these remainings were washed out by the like normal flow of after this heat exchanger was commissioned. So depending on the size of the heat exchanger, sometimes it's like 20 or 30 cubic meters, like economizers, for example, or quench water vaporizer we did for one of the petrochemicals in Russia. Depending how dirty it is also very important. So it depends. But if you maintain a certain level of cleanliness, and if the recipe and technology is optimized for a specific heat exchanger and specific fouling, so it means that we can achieve the lowest possible time of cleaning.
Yeah, I have one more. Yeah, the final question. Sorry for the too many questions. So, okay. So in this case, as I understood, the cleaning is happening because the chemical comes in contact with the fouled material. And in some cases, the tubes may be completely plugged. Some of the tubes, if they are completely plugged, does it mean that they may not be cleaned when you just circulate the chemicals through it?
Yeah, in such case, we have to open the cover and do preliminary hydrojetting to do a small holes in the completely plugged tubes. Of course, it takes much less time than full hydrojetting, and you don't need to move the equipment to the cleaning cap, just open the cover and do the small holes there. But again, the full, let's say, advantages we unlock when we go to the cognitive cleaning concept. Yeah, in this way, it's like very hard to imagine that some of the tubes will be clogged. If you maintain certain levels of cleanness, so that means that you don't really see such situation. Even if like out of 700 tubes on the cognitive cleaning concept, you will get maybe 1 or 2 tubes completely clogged. So and we do like non-disassembly cleaning, and these tubes are remaining clogged. We do not really affect the HTC. Maybe once in 5 years, you have to open it and do complete cleaning. But again, like as for like normal chemical cleaning, you need to circulation of cleaning agent.
If I may add here, gentlemen, on that what Ilya just said, and he as well, chairman of the board of ANGARA, it's like I would use a very good analogy for that. For example, if you brush your teeth regularly and properly 2 times per day, etc., you don't need to go and do kind of replacement of your teeth, etc., or major kind of work for a dentist sometime end of the year. But if you do it not properly or you don't do it regularly, of course, you need to eventually go to dentist and, well, have some painful and costly, well, exercises.
Thank you, Valerie, and thank you, Sankar, again for your contribution. If you don't mind, I need to give the floor also to our colleague, Jamila Numtairi from KNBC. Go ahead, Jamila, please.
Thank you, Emad. Regarding the chemical cleaning for the exchangers, you said your technology is capable to clean the biofouling. But what about the sea cooling water network, the cemented lines? Is this chemical capable to clean the network as well, or it will have a damage on the cement lining?
You mean pipes?
Yes.
So generally, yes, but we have to look into economics, because in the heat exchangers, the ratio between the surface and the volume is much higher comparing to the same ratio in the tubes. I mean, in terms of how much of cleaning solution we need for that. But on the other hand, we can use less concentration of a cleaning solution. So we have to look into this on the case-by-case basis. So if you can send us some details about this problem and how big is the pipe network, etc., so we can address it specifically.
Thank you.
Thank you.
Thank you, Jamila, and thank you, Sankar, as well, and Aqil. Is there anybody that have any question? Because I have the last question from my side. Okay, Ilya, I have one question. I was thinking, you know, on the preheat train in the crude unit, usually we do the mechanical type cleaning, which is very effective. How is this chemical will do a better job in the pre-train, you know, the preheated trains in the crude unit, especially if it is an existing? I'm not talking about the new existing crude unit for years. How much this will help compared to the conventional mechanical, hydrogetic or whatever?
Yeah, thank you for the question. So the key element here is how deep is the cleaning. So if you compare the mechanical cleaning, like it's very easy to clean the tubes by hydrojetting, yeah, because it's linear in most cases, etc. But if you look in the shell side, like most of our clients say that we don't achieve, let's say, 100% cleanliness. I can tell you some of specific numbers. Like one of refineries is our very important client, and we're very sophisticated in terms of efficiency measurements, always economic calculations and methods we use for the cleaning. So basically what we are saying that due to mechanical cleaning, we can achieve, so if the HTC drops below 60% from the maximum HTC, so we perform the cleaning of heat exchangers. But the maximum what we can achieve by hydrojetting the shell side is the 75%. Because it's really hard to get inside of, especially if you have a honeycomb structure of or layout of the tubes. What we plan to achieve, at least 85 or 90% cleanliness level with the same heat exchanger. Because we have like similar experience with one of the refineries in Russia, where shell site was, it's a quench water vaporizer, was almost completely clogged, and basically the refinery have considered to replace the heat exchanger by the new one. And we did the cleaning, and we achieved 87% cleanliness level in terms of like internal volume of a shell site. We measured before and after how much water fills in, and it was for one cleaning cycle. I'm almost sure that if we would have enough time to do the next like cleaning, because it was very limited amount of time we were given for the cleaning, we could achieve like 97% result. And I remind you that this heat exchanger, we didn't clean it for 4 years, and it was so dirty that the refinery considered to replace it. So that's the key advantage of the mechanical methods, because we can do a much deeper cleaning. And especially it works well, our competitive advantages are bigger with complicated heat exchanger with extended heat exchanger surface, like plate heat exchangers, like spiral, and etc., and even shell side of normal shell and tube heat exchangers.
Excellent, Ilya. Maybe, sorry, gentlemen, I am holding you that long, but as you know, in the project manager technical committee of the GDA, we care about investment as well. We need to make sure that we have efficient and the quality also portfolio of capital projects. And one of the portfolio that I am managing at the refining business, I see lots of replacement of exchangers across the process units, actually. Lots of bundles we have to replace, shells, as you know, less. So, and when you go and you talk about cognitive cleaning, how much your technology is helping us to monitor those heat exchangers performance and also look after fouling, that we should avoid any capital investments in our assets in the refinery?
Yeah, I would pass this question to Eduard.
Emad, it's a great question, and definitely we target, of course, the maximum timeline and work for the equipment, because we keep it clean. As well said, hygiene improves the lifetime of the equipment and of people, of anyone, if you had to invest time into these matters. And of course, it's a matter of how hard was the production conditions, what are the overall setup and layout of the units, because those are the things we cannot influence. But I believe with the implementation of the cognitive cleaning, it's a new paradigm and mentality of how this process is managed and implemented across the enterprise. So instead of going to doctor when it is already needs an operation or intervention, we just monitor and see if there is early signs of something getting clogged or dirty. We immediately calculate the economics and we decide, okay, it's time to clean, and we cross line. And the cleaner it is, the cheaper to clean, and the faster it goes. So that's the overall approach. Instead of heavy stops on in long cycles of cleaning, we offer very quick pit stops for like Formula 1. You just do it in 5 seconds and then drive back on your bolide. So that's basically the answer. Of course, the more work you put into, let's say, taking care and monitoring your equipment, the better the effort will be.
Thank you very much, Edward. And thank you very much as well, Ilya, for your effective contribution, at the same time clear explanations to our question today. I feel very sorry that it was a very short time. Here I would like to thank you so much, all of you gentlemen and ladies. At the same time, I was so honored today to be here, and I hope that we together have made this webinar interactive and useful, that each one of us should take away with him back, which can further develop the industry and complement our business interests. At the same time, I would like to thank all the technical committees members that attended. And to be honest with you today, I was thrilled, honored to have the 5 chairpersons of the 5 technical committees with their teams as well. I really need to thank every one of you, and especially the GDA management, for availing those opportunities to help develop our business requirements, inshallah, in the near future. I wish you again the best of luck, and thank you very much again for your attendance. Ma'as-salam.
Thank you.
Ma'as-salam.
Thank you, Emad, for an excellent hosting of this webinar.
Thank you all. Thank you. Bye.
Emad and everyone, thank you very much. Emad, very much. Say thank you for making such a quality dialogue and opening the session and moderating. It was a great honor to have such a great audience today with us, and we look forward to speak more in details with on some specific things with the team.
Raj, thank you very much as well.
Oh, of course, of course.
Thank you, thank you, Valerie. Thank you, Ilyas. Thank you, Eduard. All of
hope to see you in face in after
Yes.
this coronavirus disappears.
Sure.
Hope to see you soon.
We all look forward to a face-to-face meeting soon.
Inshallah, thank you
After we
very much.